Surface area and volumes. To understand the concept of surface area and volume, let's look at a cube. We all remember cube is a very special structure, each of whose face looks like a square. It has 6 faces, the front and back, the right side and the left side, the top and the bottom. Overall, 6 faces. This is a surface, the front surface. Similarly, you have a back surface, then right surface, left surface, top surface, and bottom surface. If you add the areas of all these surfaces, it is called the surface area of the cube. Now, if I tell you that this side was x, it could be any unit, x centimeter, x inches, doesn't matter. This will also be x, and this will also be x. So its length, breadth, and height, all of them are x. What's the area of this face? It is x into x, that's x square. Similarly, there are 6 faces. So the total surface area of a cube is 6x square, where x is length of each side. How do you find the volume? There's a very interesting way of finding out the volume. This is the base. You know that the base area of the cube is x square. Multiply the base area with the height, which is also x, and you will get the volume of the cube. X square into x will give you x cube. Alright, you have to be careful about the units. Imagine I give you a cube whose each side is 4 centimeter. What will be its total surface area? Total surface area. So it will be 6 times 4 square. 6 times 16. That's 16 6 is 96 centimeter square. Okay. And if I asked you the volume of this structure, the volume will be 4 cube. 4 cube is how much? It's 64 centimeter cube. Sometimes we write centimeter cube. Sometimes we also write cc. It's the same thing, centimeter cube. Alright. Let's go further. Imagine that there are 3 cubes connected back to back. So the structure will look like this, somewhat like this. Okay. You know, this structure looks like a cuboid. Cuboid is an extension of a cube only, which may have different lengths, breadth, and height. In this case, if I told you that these were 3 cubes, each of whose sides were 4 centimeter, this will be 4, 4, 4, and 4. Overall, this particular length has become how much? 12. And the height is also 4. If I asked you the total surface area, how will you find that out? So here you have the front and back square. The areas of the front and back will be how much? 4 square plus 4 square. That's twice of 4 square. Yeah. This side face, the right side face, is a 12 into 4 rectangle. So right and back are both 12 into 4. Look at the top also. The top is also a 12 into 4 rectangle. The top and bottom, both of them are 12 into 4 rectangles. So how many such surfaces do we have? We have 4 such surfaces: right, left, top, and bottom. So we have 4 such surfaces of area how much? 12 into 4. So overall, the total surface area will be 2 into 4 square. 16 2s are 32 plus this. 4 4s are 16. 16 into 12. So 160 plus 32. It's 182. Add these two and you will have 214 centimeters square. Okay. And what about the volume? Volume for a cuboid is actually length times breadth times height. So this overall structure has a length of 12, a breadth of 4, and a height of 4. So the volume will be 4 into 4 into 12. Multiply this and whatever you get is the answer. So 12 into 16 is actually 182 cc. All right. Cc is nothing but centimeter cube. You could write any one of these. Now imagine I have a tank which resembles a cuboid. The tank is like this. Yeah. The base of the tank, the breadth of the tank, let's say, is 80 centimeters. The length of the tank is 1 meter, and the height of the tank is also 1 meter. Yeah. The breadth, the length, and the height are given to us. And this tank, let's say it has to be filled with water. Yeah. The question is how much water can be filled in this tank. For that, do we find out surface area or do we find the volume? The answer is that we will go for the volume, because volume is how much space is contained in this structure. So the question was how much water can this hold, this structure hold? For that, let's find out the volume of the structure. The volume will come out to be 1 meter into 80 centimeter into 1 meter. Let's go for similar units. Let's prefer centimeters for the time being. So the length is 100, the breadth is 80, and the height is also 100. How much do you get? You get 8 followed by 5 zeros. 1, 2, 3, 4, 5. Centimeter cube. Yeah. In the case of water, we say that each centimeter cube is equal to 1 milliliter of water. And we also know that 1000 milliliter of water makes 1 liter. So which means 1000 centimeter cube is equivalent to 1 liter of water. Yeah, simple mathematics. How many thousands are here? In this case, you can see there are 800 thousands. So the quantity of water that this structure can hold is 800 liters. So imagine it's not a very small tank. It's a big tank which was 1 meter high, 1 meter long, and almost 1 meter, but actually 80 centimeter broad. So the water that it can hold is 800 liters, no less, quite big amount. Just to bring a simple reference to your mind, imagine I had a huge structure with each side 1 meters, 1 meter, 1 meter, and 1 meter. What will be the volume of this structure? The volume of this structure would have been 1 into 1 into 1. It is actually 1 meter cube. Yeah. 1 meter cube means each of the meters gives you 100 centimeters. So that's actually 100 times 100 times 100 centimeter cube, which is how much? Which is actually 1 followed by 6 zeros. Centimeter cube. And how many thousands does it have? It has 1000 thousands. So if somebody asks you how much water can this hold, this can hold 1000 liters of water. Yeah. Similarly, sometimes they can ask you that there was a huge iron weight or iron object whose volume was this. This was the volume, or this was the shape. This was dropped into water. It was dropped into water. So when it dropped into water, it displaced some water because of its own shape. How much water was displaced? The answer is it will displace the water equivalent to its own volume. And this again will be your answer, that the water displaced is equal to 1000 liters. water displaced by this object is equal to 1000 liters. Just for our scientific knowledge, 1000 liters is also called 1 kiloliters. Yeah, some of you may be knowing this already. Okay, let's see if we can do one more question. I have 10 cubes, okay, and which are arranged like this. This 1, 2, 3. Okay, let's take one more. So imagine there are 10 cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are arranged like this. The side of each cube is 3 centimeter. So 3 centimeter, 3 centimeter. The question is, what's the total surface area of this structure? Is how much? And also, if it has to be painted with a paint that costs rupees 5 per centimeter square. So you will find out the area, you will multiply it by 5. But if they tell you that the cost of the paint is rupees 50 per 10 centimeter square. If you look carefully, for 10 centimeter square you are giving 50, which means for 1 centimeter square you will be giving 5 rupees only. This is the same information. Okay. So if you divide this by 10 here, you'll have to divide this also by 10 so that the equivalent ratio can be maintained. Hope this is making sense to you. So either you write rupees 50 per centimeter square, rupees 50 per 10 centimeter square, or you write rupees 5 per centimeter square or per 1 centimeter square. It is the same thing. Okay. So what's the total surface area? You can see that there is a rectangle here, overall rectangle, whose length is 6, 3 and 3, 6, and whose breadth, actually the height, is also 3. So 6 into 3 is 18. You have an 18 here and 18 at the back. So that becomes twice of 18. Plus, you have this, I'm coloring it yellow for our own understanding. Yeah, look at this zone. The length of this one is 3 times 5. That's how much? 15. And this breadth is 3. 15 threes are 45. And you have the right and the left. There are two structures. So 15 threes are 45, but twice. Twice of 45. And finally, we have the top structure, which I'm coloring with blue for the time being. Look at this structure. The length of this structure is again 15, but the breadth of the structure is 6. 15, 6 are 90. The area of the top and the bottom will be combined. So twice of 90. Twice into 90. This is the total surface area of this structure, which is how much? Twice of, if you take twice common, you will have 18 plus 45 plus 90. Okay? Which comes out to be 45 plus 18, 55, 63 plus 90, 153. This will give you 306 centimeters square. This is the area in consideration right now, which has to be painted. And we know that for each centimeter square, you'll be paying 5 rupees. So for 306 centimeter squares, how much will you pay? Total cost will be 306 times 5. 6 5s are 30. 3 5s are 15. Rupees 1530. 1530 rupees. All right. And in case they asked you the volume of the structure, the volume of this structure will be how much? The length into breadth into height, which is 15 into 6 into 3. Am I right? 15 3s are 45 and 45 into 6. So 45 2s are 90, 90 3s are 270. So the answer will be 270 centimeter cube. Okay. In case they asked you that this structure is dropped into a vessel full of water, how much water will be displaced? Your answer will be 270 cc, which is the volume of the structure itself. Okay. I hope this basic introduction was useful. When you are done with this video so far, kindly try these questions. This is your task for today. You can stop the video here and you can copy down the questions. Do them carefully and submit on the Veracross. Thank you.